That's so weird.
Isn't that cool?
You don't see it?
Wait, you can see it?
No.
You can see it?
How did you get to see
Oh man. Okay, so what happened and why did that
it? Wait, I
happen?
thought we were supposed to see it. I saw it.
Nate didn't see it.
I didn't see it.
I
He
didn't
was
see
at a
it.
bad angle.
What was I even supposed to be looking
Oh my
at?
gosh.
Do it again.
I've got a little bit of water in there just because when the water turns to steam, the steam more, like we talked about heat, the steam more effectively heats up the air inside there. And then once I get this really nice and hot inside, I'm gonna flip it upside down. The reason I wanna flip it upside down is because look at the opening there. I wanna seal up that opening right away. So I'm gonna seal up the opening by sealing it with the water. Does that make sense? So I'm gonna flip it upside down so the water seals that opening right away. And then how is the temperature gonna change when I flip it upside down into the ice bath? What's gonna happen to the temperature?
It's gonna decrease.
Temperature's gonna rapidly decrease. So is that going to affect the pressure and the volume actually, but let's pay attention to pressure. Whoa, that's a good one, isn't it? Yeah, I guess this is fire, but it's a little fire. Okay, so I'm gonna heat up the air inside here. And that might take a little bit because it's just a tiny little candle. But then once I heat up the air inside here, I wanna cool it back down. And the reason I wanna heat it up first is because I want it to get hotter than room temperature, because when I cool it down, I'm only cooling it down to room temperature. I'm not using an ice bath or anything. So if I heat up the air inside here, then I'm again gonna put it in upside down. So the water, this is just colored water. So the water is gonna seal up this opening so no more gas can get in or leave. So right now it's open to atmospheric pressure, right? So whatever pressure's out here is the same as the pressure in there because it's all open. So gas molecules can come in and out. But as I'm heating it up, then I'm gonna put it in there and seal it up. And then it's not gonna be over the fire anymore. So what's gonna happen to the pressure of the gas, or what's gonna happen to the temperature of the gas inside here?
The glass is gonna explode.
The gas is not gonna explode.
That'd be cool.
Once I take it off the fire, what's gonna happen to the temperature of the temperature of the gas inside here? It's gonna decrease because it doesn't have a heat source anymore. And as the temperature decreases, what did we just see will happen to the pressure? As the temperature decreases, what's gonna happen to the pressure? It's gonna decrease in there, which means the atmospheric pressure now is going to be greater.
It will explode.
It's not gonna explode.
Darn it.
The gas will not explode. Think it's hot enough?
The glass will shrink.
Alright, let's try it.
Oh, well, that's cool.
That's not what I thought would happen.
It has like a pulling force when you pull it up from the water.
Not pulling, but
Pushing.
pushing. So what's no, science never sucks, it only pushes and pulls. Whoa, see? Okay, so what's pushing? So if it's pushing, what's pushing?
Water.
Where is the greater pressure? Inside or outside?
Outside.
Outside. So the atmospheric pressure now is pushing. It was because if we get better, if we get a bigger temperature difference, we're gonna be able to see it better. Especially with this long neck. I was hoping to find a flask with a shorter neck, but this will do. Okay, nice and hot. Nope, I'm just gonna set it right on top. And then I'm gonna put the egg in the ice bath. So what's happening to the temperature of the gas inside the flask right now? What's happening to the temperature?
I see it.
Oh, that's...
Temperature is decreasing, which means the pressure inside is decreasing, which means the atmospheric pressure out here is pushing
Why does it look like that?
the egg in there.
How do you get it back out?
Okay, how am I gonna get it back out?
Oh, it's
Heat it
gonna...
back up.
So let's seal it up. Let's seal it up and let's heat it back up. So now as we increase the temperature of the air inside the flask, what's happening to the pressure?
It's gonna push it. Oh my gosh.
Pressure is increasing
It's kind of cool.
and we're gonna push it right back out.
You do that with the soda key?
You're a good magician.
No.
Whoop.
What? Look at that.